Hello friends, welcome to Raja's Data Engineering. In this video, I'm going to talk about Delta Live Tables. Delta Live Tables is one of the advanced feature provided by Databricks. With the help of this feature, we can build data pipelines efficiently. And nowadays, most of the projects started using this concept very commonly. So, as a data engineering developer, it's very important to understand this feature. And in order to give the complete information about this feature, one video is not sufficient. It is going to take more effort and time. So I have splitted this tutorial into multiple videos. So I will cover this entire session, entire knowledge across different videos. So in this first video, I'm going to talk about only the introduction. At the end of this video, you will get some idea what is Delta Live Table, what is the importance of that, how it is different from regular pipelines, and why we have to use Delta Live Tables in our project. You will get answer for all these questions. At high level, you will be able to define what is Delta Live Table. Before getting into Delta Live Table, it's important to understand Medallion architecture. Medallion architecture is one of the common or standard architecture within Lakehouse. Lakehouse is nothing but it's one of the data platform which is combining the best features from Delta Lake plus data warehouse. So within the Lakehouse, Medallion architecture is very common, which is having three layers: bronze, silver, gold. And the ETL pipeline will connect to different data sources and it will ingest the data and putting the raw data into the bronze layer in the raw format itself. This is mainly used to consolidate raw data from disparate data sources. Once that is done, then in the next layer, the data cleansing, data validation process is applied. We are having some null value. Either we have to remove the null value or we have to put some default value to handle the null value. So those kind of cleansing operation, even if you have duplicate value, that can be removed. Or let's say we have a date format from different source systems, we are receiving the date format in different format actually. So in one of the source system, we are having year at the beginning. In some of the source system, we are having day number at the beginning. So, but coming to our system, we have to follow some standard pattern. So those kind of data confirmation or data validation checks are performed within the silver layer. Once we have done, then in the cold layer, the core logic according to the business use case is applied. It could be various transformations or business aggregations. Once we have completed the data transformations and aggregations, then the final data can be supplied to different consumers. Different set of consumers can consume the data from gold layer. This is the standard Medallion architecture, right? But when I'm talking to Medallion architecture or I'm showing this diagram, it's very familiar to you. You might have seen this diagram in multiple places, but whenever I'm explaining, it looks very simple because we are having only one component for each layer. Here I have given one interaction component that is nothing but bronze layer, and similarly silver, gold. But in the real time, whenever we are scanning through the lakehouse architecture, it's not going to be that simple that I have shown here. In real time, the Medallion architecture that is going to be more complex, or any ETL pipeline that we are building, that is not going to be very straightforward. It is not going to just receive the data from data sources and directly it is moving from one table to another table and then from that to another table. That is not going to be the case. In real time, our data pipeline, it is going to connect to various source systems, and within each layer we are going to have multiple objects or multiple schemas. Even one particular layer that can be divided into multiple, logically can be divided into multiple layers inside. So we will have multiple different data objects. It could be tables, views, managed table, external table. There could be different types of objects we will have, and the dependency between these objects would be complex. For example, if you look at this particular table, this is depending on this one, and this table is depending on this table, and in certain cases it could be even more complex. For example, these two tables are depending on this particular table. So here we can see the real-time architecture, how it looks like, and this is a bit complex. And even for this diagram or this demonstration, I have given some limited complexity only. But in the real time, when you are going to look at some architecture, it's going to be even more complex. So when we have such complex architecture, what are the problems we will have? that is what we have to understand, because delta live table that is going to address those issues later. So first of all, let us understand what is the problem we are going to face with this kind of complex architecture. So first of all, troubleshooting and debugging is going to be very challenging. Why? Because in this particular current approach, whenever we are building ETL pipelines, we are going to monitor the status at pipeline level. So at component level, for example, we are not going to monitor the logic only for this particular component. We are going to monitor the logic at pipeline level. The pipeline which is responsible to ingest the data from different sources and applying certain validations and transformations. So we don't have a proper monitoring mechanism for each logic. So that is the reason it is going to be difficult in terms of troubleshooting and debugging. Because of that, it is going to take more time, and also it is going to be more manual work. And second thing is, coming to data quality, it's going to be poor, and at each and every stage, manually we have to write a lot of code in order to handle the data quality. And we don't have any mechanism to monitor those data quality checks. Let's say we are having some corrupted records, or there are certain records which is deviating from the standard. Then we don't have any metrics how many records violated those standard. So we don't have any mechanism. Maybe manually we can create some table, error log table, or we can create some location in the Azure data lake storage in order to track those failed records. And it's going to be time consuming in order to create that manual logic in each and every place. So data quality that is going to be poor, and we need to handle that manually. And the next important problem is data lineage is not available. When we are building the ETL pipelines at high level, we don't have the data lineage. What is the dependency we are having between different components that we don't have. We don't have any tool to monitor those lineage. For that, we have to manually document. We have to understand the code, and manually we have to document. Or each and every time we have to go through the code in order to understand. Let's say there is some problem with this table. So in order to fix the issue, first of all, we have to understand what is the what is the dependency of this table. What is the downstream and upstream objects. For example, this particular table, this is depending on these two tables. So here in this diagram, visually we can see this particular table that is depending on these two. And for this table, this is the consumer. So we don't have any such mechanism to monitor the lineage visually. Instead of that, we have to go through the code, and through the code we have to understand. For example, we have certain logic for this table. At the end of this table, this is going to load the data into this table. Something we have to understand manually through the code. Then we have to understand the lineage. Then we have to fix. So we don't have any proper lineage. And the next thing is, we have challenges with monitoring and visibility at the granular logic level. For example, we don't have any metrics or statistics for each logic. For example, we are having some logic in order to populate this data, or we are having certain different logic to populate this table. So at the end of the completion, we are going to have the complete status at the pipeline level. We are not going to have any statistics related to particular logic. How many records got processed for this particular logic, and how much time it has taken. So we don't have any information. So for that, again, we have to go through the uh, pipeline, and we have to understand, or we have to go through Spark user interface. Then we have to understand how much time it has taken. So we don't have any centralized tool or location to track and monitor the progress of the pipeline. And the last challenge would be combining the batch and streaming process. In today's big data world, streaming process that is very common. And for most of the fact or real-time data, we are using a streaming process. But for most of the dimension tables, still we are going with static data. So batch processing is applied for dimension table, and streaming data that is applicable for fact tables. And in certain time, we have to connect, we have to join fact and dimension tables. So for that, we have to mix batch and streaming process. Even though this option is available within Databricks even before Delta Live Table, but that is quite complex compared to the Delta Live Table approach. So this Delta Live Table can simplify that process as well. So these are the challenges with current ETL pipeline building approach. I hope you understood, right? Let us keep this aside. Now you understood what is the current architecture or ETL building approach and what is the problem we are facing. We can keep that aside, and now we can focus on what are the steps we need to follow in order to build ETL pipeline using Databricks. So there are several steps in order to complete the ETL pipeline. Starting from design until deployment, we have to take care of different components, different processes. So I have already summarized here in this slide. You can see, first of all, we have to perform the code development. Now, this is the main purpose. We are hiring developers. So they are good in understanding the requirement and applying different data transformations on the source data, then pushing the data into target environment. So this is the core part of any ETL pipeline. And apart from this code development, the developer should concentrate on cluster management. Like, what kind of cluster we have to go for, what should be the compute power for each cluster, how many number of worker nodes we need, what should be the memory size, number of cores for driver and worker nodes, and auto scaling is needed or not, auto termination is needed or not. We have to put a lot of effort in terms of cluster management. And for development, we can go with all purpose cluster. For production, we can go with job cluster. So for those clusters, we have to define the template, right? And apart from that, the developer has to focus on data quality checks. Whenever we are receiving data from different source systems, it will come with a lot of data defect. There could be some problem with the data quality, like there could be some duplicate value, some null value. So data quality checks, that is another important part in any ETL pipeline. For that, Databricks developers has to write a lot of logic in order to handle the data quality manually. So this is another aspect while developing the solution. And the next thing is infrastructure management. So like as I mentioned earlier, cluster management, that is also one of the infrastructure management. Apart from that, we have to look into Spark user interface in order to understand the health of executors, worker nodes, driver node. We have to manage the infrastructure. We have to monitor and we have to make some corrective action if something goes wrong. So infrastructure management, that is another important aspect of development. And dependency management. Dependency management is nothing but understanding the data lineage. How one particular logic or one particular table that is related to another tables. That is very important because with the help of that, the debugging or troubleshooting will become easy. So for that, we have to go with documentation. Manually, we have to document, or each and every time we have to go. Developer has to go through the code in order to understand the lineage and make necessary changes after understanding the lineage. So dependency management, that is also one of the important aspect each developer has to focus on. And apart from that, fault tolerance. Fault tolerance is nothing but whenever data pipeline is getting failed, then how we can handle that failure scenario. So we can for that now we can go with the different approaches like a retry, or manually we can debug and troubleshoot. After that, we can rerun the pipeline manually. These are the steps we can take for fault tolerance. That is also manual process. And apart from that, data governance. Data governance is nothing but what kind of data we are receiving, what is the life cycle of that, and who can access that data. These are coming under data governance. Any developer has to focus on data governance as well. And the final thing is production monitoring. Once the pipeline is created and it is scheduled in production, then it should be monitored time to time. If there is any issue with the pipeline execution, then that should be fixed. So currently, we don't have any centralized location where we can go for monitoring. So these are the different components or processes or aspects each developer has to focus while developing the pipeline. Now we understood what is the challenges with the current architecture and what are the steps we have to go through while developing ETL pipelines. But coming to these steps, one thing we can notice, code development, that is a core part. Whenever we are hiring certain developers, the developers should be able to transform our data. As long as we are getting the quality data, we don't need to, we are getting high quality data, we don't need to perform any data validation. Let's assume then the developer can focus only on the core logic, the core business requirement. Now, whatever the requirement or business aggregation transformations we got from business users, only we can focus on that part. So this is the core part. So coming to these steps, any developer has to focus more on code development, and all other steps it is not necessary for developer. there should be some framework or there should be some mechanism to handle all these processes automatically. Then we can speed up our development. So the developer can focus only on core code development instead of focusing on the tool and processes. So this should be the ideal steps needed to develop a pipeline, ETL pipeline. But currently, the developer has to focus on the development along with he has to focus on tools and processes. So if we get a framework or mechanism to eliminate these components and the developer can focus only on code development, then it is going to be accelerate data pipelines, and it is going to give efficient data pipelines, right? So for this particular scenario, now we understood if we are having developers, they are going to focus only on code development, then that is going to speed up the development process. Now, what is the solution for that? So the solution is nothing but Delta Live Tables. So Databricks has come up with some framework. Developers can simply use that framework, and with the help of this Delta Live Tables, developers can focus only on the code development, and remaining other processes or other components will be taken care by Delta Live Tables. So I'm going to cover all the functionalities through multiple videos. So once I have covered all the videos and you understood all the concepts, then you can relate how Delta Live Table is efficient and how developers can focus only on the code development instead of focusing on the tool. Right. So Delta Live Table, which is going to give a framework. With the help of that framework, developers can produce efficient ETL pipelines. Right. So according to definition, what is Delta Live Table? Delta Live Table is a development framework provided by Databricks, which simplifies and accelerates ETL pipeline building process. And coming to concept, Delta Live Table is using declarative approach. In our current approach, in our regular ETL pipelines within the Databricks, we are following procedural approach. And coming to Delta Live Table, it is following declarative approach. This is one of the major change, and it's very important to understand declarative and procedural approach. In my next video, I'm going to cover what is the difference between declarative and procedural approach. When you understand these two, then it will be easy for you to understand the purpose of Delta Live Table, or how it is efficient and how we can use in our day-to-day development. Right. And coming to Delta Live Table, that is automatically managing the infrastructure at scale. And with the help of this Delta Live Tables, engineers can focus only on developing core solution instead of spending more time on the tooling and process. So this is the summary of Delta Live Table, right? And let me list down the advantages of Delta Live Table. Coming to Delta Live Table, it will perform the data transformations internally. It will manage all the transformations within a Delta Live engine. So we have to just declare what kind of transformations we need, or what kind of end output we need. Then Delta engine will think internally, and it's a smart and intelligent engine. So it will think the best approach, and it will start applying all the transformations automatically. So in the procedural approach, we have to define all the transformation steps one by one manually in proper order, and the Databricks engine that will execute all the steps one by one. But coming to Delta Live Table, we have to just tell what we want. Then it will start thinking what kind of transformations it has to apply and how it can arrive to that final output. So this is very simple. And coming to cluster management, explicitly we don't need to create or manage any cluster. We have to just create the Delta Live Table workflow. Internally, it will manage the cluster management. Coming to data quality validation, in regular Databricks notebooks, we have to use null handling, different logics to handle null or duplicate handling, different data validation, data quality checks, or data confirmation activities. We have to perform manually through coding. But coming to this declarative approach, we can just tell what kind of data quality we are expecting. For example, one of the particular column that should not accept null value, or one of the particular column it should not accept any value greater than certain limit. So we can just tell during the declaration, then automatically it is going to manage all those data quality validations. And with the help of these things, the entire ETL pipeline will be accelerated. And coming to task orchestration, as I told earlier, we can just tell the Delta engine what we want. It will just think internally how it can be done. So basically, it is going to orchestrate all the internal task one by one. Then it will execute them manually. It will manage them internally. So we don't need to manage that explicitly. And coming to monitoring, this is one of the important component of Delta Live Table. With the help of beautiful UI, we can monitor for each and every component in the entire pipeline. We can understand the metrics. For one particular table loading, how much time it has taken, how many records it got processed, how many records got removed due to this data validation. We can get all the metrics. We can still we can get many more metrics, many more information from the user interface. So it's one of the efficient centralized platform to monitor the Delta Live tables. And coming to error handling, we can give retry. There are some options provided by Delta Live tables. With the help of that, error handling can be handled efficiently. The retry option can be used, so Delta Live table will automatically retry. And also, if one of the particular logic failed internally, then we can start the re-execution starting from that particular logic, which is not possible with the procedural approach. In current procedural approach, in case one of the particular pipeline failed, then we have to rerun the entire logic starting from beginning. But Delta Live table, that is giving efficient options to handle the error. And finally, Delta Live table, that is giving option of handling batch and streaming process together. So these things we will see while I am covering the coding process. Now we are trying to understand what is Delta Live table. So I am not going to cover any coding approaches now, but in one of the video I will cover development steps. Then you will understand how unified this batch and streaming process can be handled in unified way. Right. Now let me summarize. In order to create a Delta Live table, what are the steps we have to follow? So there are major 4 steps we have to follow. First thing is we have to create live tables using notebook. So what is live table? There are different set of live tables and materialized view in Delta Live table. I will cover those concepts in one of the video. So basically we have to define the logic we have to create different live tables by defining a set of logics. So for each and every live table, we have to tell what we want. We have to define certain logic through declarative approach. So this is happening within regular Databricks notebook. So how we are developing a procedural logic in the regular notebook, same way we have to create the logic within Databricks notebook. But one of the major difference compared to procedural approach is, in procedural approach, we can execute each and every cell during the development in order to test the logic. But coming to Delta Live table, we cannot execute that in regular notebook. So once we have defined all the logic, we have created Delta Live table pipeline, then we have to create a workflow. That is the second step. For that, we have to get into workflow in Databricks. Then we have to get into the Delta Live tables tab. Then there we have to create the workflow. There we have to choose the notebook which we have developed in the first step, and also we have to configure different parameters which are needed for this particular workflow. Those things I will cover later, you will understand. And once we have created our Delta Live table workflow, then finally we can run that immediately, or we can schedule that for a particular interval. Then once we have executed the pipeline, then we can monitor using the user interface provided by Delta Live table. These are the high level steps that we need to follow. I hope you understood the introduction of Delta Live table. What is the current Medallion architecture and what is the complexity of that? And in order to eliminate those complexity of the pipeline, what is needed? I hope you understood. Hope you enjoyed this video. If you like the content of this video, please like and comment in the channel. Please subscribe this channel and don't forget to click on the bell button to get latest video on Databricks. Thank you.